Okay, this is going to be an example of graphing a rational function. I'm going to use that same three-step process we walked through in class in case the structure helps. But basically, as long as you get all these components in there, you're good to go. So we're going to work with the function f of x equals 1 over x plus 2. That's our rational function. And the first thing I want to talk about will be the domain. So I'll just call step 1 here, talking about the domain. And we've been talking about domain actually since the beginning of this chapter, and domain really means what values of x are okay to plug into your function. And often to talk about what's okay, we talk about what's not okay. So in this case, the domain is going to be all x's except for one value. And that one value comes from thinking about the denominator here. So if I think about x plus 2, what would cause that denominator to equal 0? So you can set it to 0 and solve, and you'll find, well, negative 2 is the value that would make the denominator 0. That would mean you're dividing by 0, which is undefined. So the domain says everything but negative 2 is okay. That kind of implies then that this new part, this vertical asymptote part, is going to be equal to negative 2. When we get to the graph, I'll talk a bit more about that. But whatever the domain does not include, that's what the vertical asymptote is. So this first step helps us with the second step, which I'm just going to call building the table. And I would like for us to get 3 values on either side of the vertical asymptote. So as I build the table here, I'll choose 3 values of x to the left of, in our case here, negative 2. Then I'll put in negative 2, and then I'll choose 3 values to the right. So I'm going to go ahead and put that value of negative 2 in the center of my table. Remember, that's where the function would be undefined. If you were to try to plug in negative 2 back up here for x, you would be dividing by 0. And if I look at values to the left of that, let's look at things like negative 3, negative 4, negative 5. To the right of negative 2, I'll just grab negative 1, 0, and 1. Now we need to plug those in to get the y value. So if I take an x value of negative 5 and plug him in place of x here, I now have a negative 5 plus 2 in the denominator. And negative 5 plus 2 is just negative 3, so my answer, or the result for the y value, is just 1 over negative 3. So it's maybe a little easier to think about that as a negative 1/3. I'll run through that same process with my next value here of negative 4. Negative 4 plus 2 would be negative 2. So 1 over negative 2 is really the same as just negative 1/2. You can use decimal approximations if that's more comfortable. And finally, with this value here of negative 3 plus 2 is negative 1. 1 over negative 1 is just negative 1. Alright, so that's a little cramped, sorry about that. But let's take the 3 values to the right of the vertical asymptote now and do that same process. Negative 1 in place of x. Negative 1 plus 2 is 1. So I get 1 over 1, which is just 1. Grab that value of 0, think about him. 0 plus 2 is 2. So 1 divided by 2 is just 1/2. Finally, plugging in 1. 1 plus 2 is 3, so I get 1 over 3, or just 1/3 for my final y value. So hopefully that helps a little bit with building the table. This pattern is fairly predictable with simple rational functions, which is about as much as we'll see here in our class. They, of course, can get more complicated down the road. But now let's try plotting these points. So I have 3 points on either side of the vertical asymptote. I'm going to move my table over fresh here, so there's that same table we just worked with. And I am going to show plotting these points. So remember that when you have a table of values, you really just have sets of ordered pairs. What I mean by that is, when I look at the table, this first point here is really the same as the ordered pair negative 5, negative 1/3. So when I plot that on my graph, I'm going to go to -5 on my x-axis. So here's -1, -2, -3, -4, -5. Positives, of course, on the other side. And when I go left by 5 units, I then need to go down by a -3rd. So I'm going to let this here represent going down by 1/3, because I'm going to let that be -1. So that's about a -1/3 right there. And that would be my first point. So this first point I have going right here is -5, -1/3. I won't label on the point because I can't write that small here, but hopefully that makes sense. Okay, let's try out our next point. Our next point here in the table, if I write it as an ordered pair, would just say -4, -1/2. That tells me to go back to an x value of -4 and then drop down by 1/2. I'm going to plot that point right here over on my axis. This place right here would be -1/2. And we'll go again with our next point. Kind of the pattern is developing. So x is -3, y is -1. He is going to be right down here. Okay, so I see those 3 points. I'll wait to connect them till I get the rest in. I'm also going to sketch in our vertical asymptote. We can use just a dashed vertical line to remind ourselves that the function will never cross that line. So it's kind of our barrier there. And then as I pick back up on the other side, I'll get this point out of the way so you can see a little better. When we pick back up on the other side of our vertical asymptote, I'll start here with this point of -1, 1. When x is -1, y is +1. So I'm using that to represent 1. This is going to be a half in just a second, and this will be a third. When x is 0, y is 1/2. And last but not least, when x is 1, y is a third. Okay, so we have our points there. I'll just connect them, and then that's pretty much it. Remember that this graph is curved, so don't connect your points with a straight line. The reason I'm asking you to do 3 on each side is then hopefully you'll be less inclined to use a straight line. With 3 points, we kind of get a better feel of the curve. So again, I'll get close to my vertical asymptote, but I won't ever cross it. And this side here, let me just make a little bit more space. You know what the table says already. So this side here, it will just kind of grow, but it will actually never pop up above the x-axis. So that's sufficient there. On the other side, kind of same idea. Here I'll get close to my vertical asymptote but never cross it. And then I will approach the x-axis but never cross that guy either. So hopefully that helps. A little bit messy, but those are the steps you can take as you graph your rational functions. So let me get the table out of the way real quick here, give you one last look at the graph, and that would be it. So this graph here now represents the function f of x is equal to 1 over x plus 2. And that would be it. Hope that helps. Happy studying.